Hey, how's it going? This is Mr. Hernandez, and I'm gonna go over how to determine the end behavior of polynomials. And so this is a polynomial end behavior reference image, and that's basically it's going to be your go-to for describing the end behavior for polynomials. So the point of this is just to focus on the leading term here, which means that it has the highest degree exponent. And we're going to basically determine the end behavior based on what this first term looks like. So an example, and I'm going to give you, you should maybe pause the video and draw these boxes, draw this box here with 4 spaces, and then we're going to include an example and then a example graph for each of these. So if you want to pause this now, to copy these notes down, and then unpause it when you're ready to go from there. So the first example of this one could be something like 2x to the third. And so this n is odd, which is this one, right? The exponent is odd, which is here. This is the exponent. So we're focusing on the exponent being odd, and then we're focusing on a being positive, which is this coefficient. And in this case, this is positive. Now, whenever you have an odd exponent and a positive coefficient, your graph will end up looking like this. It'll go down and left. Stuff would happen in the middle. This middle behavior can differ, but the right side will go up. And so I would recommend highlighting both of these end behaviors. The left goes down and the right goes up. Okay, an example of when n is odd and a is negative is negative 2x to the, let's say, fifth. So again, the exponent is odd, which is n. That's why I have it here, and then the coefficient is negative, right? This number in front is negative. And so if you have that combination, this could have been a 3, this could have been a 7, this could have been a 9, any odd number, 13, 15, as long as this is odd and this is negative, any negative value, the end behavior will be as follows. The left arrow will go up. Stuff will happen in the middle. We don't know exactly what's going to happen. But the right side will go down. So let's highlight that. You can see that it's basically a flipped version of its positive, the positive coefficient, right? So this was an odd exponent, positive, negative. So you're basically like flipping it upside down, which is pretty much what happens, right? When you change the leading coefficient to a negative, it reflects it going upside down. Okay, so next one is an example of when n is even and the a is positive, could be 3x to the fourth. So n is the exponent, and that's even. A is the coefficient, and that's positive. So if you have a combination of those two, you're basically going to have the left going up, stuff happening in the middle, we don't know, and the right end behavior goes up. And so I'm just going to pick a different color, but I recommend you highlight this. And then the last example is when n is even and a is negative. An example of that could be negative 3x to the fourth. So n is the exponent, and that is an even number, and a is the coefficient, and that is negative. So if you have that combination going with the leading term of a polynomial, the left and the right will go down, and then stuff's going to happen in the middle. We don't know exactly what. So we're just focusing on end behavior. So go ahead and highlight those two. And so again, because this is a negative version of this one, 3x to the fourth, x to the fourth, this is a negative 3. It's going to be the reflection of this one going upside down. So let me give you another example of each, just so you can, you know, kind of be comfortable with having different values. So this could be, instead of a 3, this could be a 5 or a 15. That's an odd number. And this could be, instead of a 2, this could be let's say 13. So it's still positive, the coefficient's still positive, the exponent's still odd, the left is still going to go down, and the right's going to still go up no matter what. Stuff's going to be different in the middle, but we're just focusing on the left and the right ends. So let me do an example, you know, maybe down here. As long as let's see, instead of 4, let's pick another even number. Let's say 88. And instead of negative 3, we want it to stay negative. So let's make it another negative value, negative 11. Well, we are still going to have the left and the right ends both go down. And the middle might be different, but still, the left and right would still go down because the coefficient is negative and the exponent is even. And so you can, these are just examples, which are nice to see, you know, what it might look like. But yeah, I'm going to do another video of how to use this image to be able to apply to real actual polynomial functions.